Hey, McDonough Middle School class of 2026. It's Mrs. Kilday. Can you believe it that we're already into our first full week of May? Today I'm going to be going over your lesson for May 5th. This lesson is going to kind of be an introductory and review as we start looking how energy flows through the ecosystems. That's going to then lead us to talking about what happens when there's disruptions in the ecosystem. And then finally, we're going to look towards the end of May at some of the relationships within the ecosystem. So I'm going to start with talking about and reviewing some of the terms that you're going to see as we are talking about energy and its movement through the ecosystem. So let's start with talking about how is it that energy flows or moves within the ecosystem. Well, the first thing that we want to be aware of is that in order to live, an organism has to obtain energy for things like movement, to help all of your organs live, reproduction. Anything that's needed to sustain or to have life requires energy. But where does all the energy come from? Well, all of the energy that we use for life originates through pockets of energy from the sun that we call photons. So sunlight is the main source of energy for all life that is here on Earth. Now, as the photons move from the sun to the Earth, they are used as energy by organisms called autotrophs. Autotrophs, also known as producers, are able to use energy from the sun to make fuel, to make organic molecules such as sugar to produce their own food. So in other words, autotrophs, also known as producers, are able to use energy from the sun as well as some other things like carbon dioxide, water, and produce food to live. The best known autotrophs that harness or use the power of the sun through photosynthesis are what we call plants. They use this energy to convert carbon dioxide and water into oxygen and glucose. Glucose is also called sugar. The second type of autotrophs that use energy to make carbohydrates are many forms of bacteria. Now, if you think about an autotroph being able to produce its own energy, I can't go out and stand in the sun for years on end and just put my arms out, soak in the sun's rays, and be able to produce my own food. Therefore, I'm not an autotroph. But if you think about your plants that you see outside, and especially this time of year as the leaves are starting to blossom and the plants are coming out of their hibernation, you will see that the plant out there with their leaves is able to take in the sun's energy plus the carbon dioxide that we exhale, water from the water cycle, and produce sugar, glucose, and their waste product, oxygen, which is what we end up using as to breathe. Now, after producers, we have what are called consumers or heterotroph. These are the organisms that rely on other organisms for their energy. So these are the organisms that either consume a producer, meaning they eat some kind of plant or bacteria, or these consumers might eat another consumer, another animal that has eaten the grass or the leaves, or consumers can eat a combination of both plants and animals. So depending on what you eat depends on the term that we use. So a herbivore is going to be a consumer that only gets its energy by eating plants. Herbivores tend to have very flat teeth for grinding. So think about your molars towards the back of your mouth. Those are there to help you grind up food. Carnivores are organisms that only eat animals. So they only eat other consumers. So these tend to be a little bit higher in the food chain in our food webs, which you're going to hear more about in our next lesson. Omnivores. Omnivores tend to eat both plants and animals. Scientists usually can identify omnivores by, again, looking at teeth. Omnivores tend to have canine teeth or sharp teeth towards the front for ripping and tearing, and tend to have flat teeth towards the back for grinding and chewing. We have scavengers that feed on the remains of plants and animals and other dead matter. And then finally, we're going to learn in an ecosystem, we have something called decomposers. These help to break down organic matter that is found in our environment. Now, energy flows or energy moves through an ecosystem, but it only moves in one direction, meaning that energy has to go from the sun to a producer to some kind of consumer. Now, looking at our video here, our diagram here, you see that there are various consumers or heterotrophs that will consume the producer. So here we see, a tree or a flower can be eaten by a rabbit. That also can be broken down into decomposing. There can be many other organisms, deer, other animals that eat those trees as well. But what I want you to notice is that the arrows only go in one direction. The sun's energy goes to the producers, and the producers use that energy, or those photons, those packs of energy, to help produce that glucose or the sugar. That sugar, once produced, cannot go back into energy of the sun. It has to continue in a one-way motion into the consumer. Now, this rabbit, our consumer, he could be consumed by another organism, another consumer, but the rabbit isn't going to be consumed by a tree. Okay? Thinking about, other than a few plants like the Venus flytrap that are kind of outliers, most plants don't eat animal insect organisms. They are the ones that are consumed. So we say that energy flows in one direction. Now, one thing I want you to notice, because you're going to hear about this in a later lesson, is that although the energy flows in one direction, it doesn't always go directly from organism to organism. So, for example, here we see the tree. Well, the tree is losing some of its energy to heat. It's also losing some of its energy to the organism that's consuming it. And when you think about this rabbit, he's consuming the plant, but he's using that energy to live. He's using it to help heat his body. He's using it, or she's using it, for movement, for digestion. So whatever might eat this rabbit isn't going to get all of the energy that's gone right from the tree to the rabbit to the next consumer, because some of the energy that the rabbit's eating from the tree is being turned into another form of energy. We're going to talk about this a little bit more next Tuesday in our lesson about how energy moves through the ecosystem and why it takes so many producers. Why do we need to have so many organisms that can make their own food in our ecosystem in order to sustain life? So in review with our energy flows originates from the sunlight. It is the source of energy for almost all living things. That energy is then used by producers, plants that use the energy in the sunlight to make food. Those producers then are eaten by consumers. That first consumer is going to be what we call a herbivore, because that first level consumer is going to eat that plant directly. That first level consumer is then going to be consumed by another organism higher up in the food chain, another part of the food web, which you'll learn about next Thursday. So that consumer, or the prairie dog, he might eat a producer and a consumer. He might just eat the consumer. Now in this case, a prairie dog is most likely just going to be eating the consumer. But remember that the energy is flowing in one direction. It's going from the sun to the producer, or the plant as we commonly know them, the autotroph that can make its own food, onto the consumer, so onto the prairie dog, and then onto the next level consumer, which in this case is going to be the coyote. Now, there are some other consumers that we call scavengers. So for example, a turkey vulture is a scavenger. This is a consumer that after the top level consumer has eaten all of the organisms, it's going to go and pick at the bones and make sure that every piece of energy that's available, or meat, tissue that's available, is consumed. After the scavengers have come through and completely picked the bones clean, decomposers are going to come and break down even further what is left. So they're an important part of our energy flow. And we'll come back and talk about them in a little bit as well. Now, one of the things you're going to notice is for today, there is a reading that is available for you to read, and it just gives you a little more detail about these ecosystems in a community of living organisms and how they interact with one another. One of the things you're going to notice in the reading is that there is a triangle. And we're going to be talking more about this triangle over our next two lessons. And noticing that at the base of the triangle, we find the word producers. So remember, that's that first level autotroph that's able to use the energy from the sun to produce its own food, glucose. Producers are then eaten by what we call the primary consumer. We often think of the word primary as meaning one or the first. So notice that the base of my triangle is broader. There's more producers than there are consumers. Primary consumers eat the producers, and then as we go up the triangle, you'll see that the primary consumers are then eaten by the secondary consumers, and then finally, in this example, we only have a third level of consumer. It's pretty unusual to have our consumers go up much more than that. So if you're interested in learning a little more detail, or you want to kind of go back over what I was talking about, I would highly encourage you to read this. Now,